Hi, let's talk about the kinetic molecular theory. So this theory has 5 postulates to it, and there are a couple of driving thoughts behind it. Here's the first one. This theory applies only to ideal gases, and this is a little bit of a circular argument. These 5 postulates actually define ideal gases. If a gas follows these 3 postulates, then it's qualified as an ideal gas. So in reality, it's going to be gases really close to living conditions. So like room temperature, 1 atm, they're going to behave with these 5 postulates. So an ideal gas, here it is. You want to know what an ideal gas is? It's those 5 postulates. Now, I wanted to put in one more thing about the kinetic molecular theory. This only applies to gases. Every once in a while, I'll have students doing an FRQ, an essay, and they will apply these postulates to a solid or a liquid. These postulates only apply to gases. So here are the 5 postulates. Number 1, gases are in constant random motion and they move in straight lines. I call them maniacs. They're individual, really far apart. They'll move on a straight line, hit something, bounce back, and go in another trajectory. So you have all of these crazy gas molecules moving completely independent in straight lines, constant random motion. So again, maniacs. Number 2, gas collisions are elastic. Now what elastic means is that when gases collide with one another or with the container of a wall, they don't lose any energy. So think about playing pool, billiards. You're going to have the cue ball and the 8 ball. They hit and bounce back. Well, an elastic collision is when they hit and bounce back, they still have the same amount of energy, now going in the opposite direction than they had going in the forward direction. No energy is lost, no energy is transferred. All the energy inside that gas molecule stays in the gas molecule even after a collision. So we say gas collisions are elastic, they don't lose any energy. Third, there's no attraction or repulsion between gas molecules. Now this is really important. It means gases have no intermolecular forces, no IMF. So when we talk about hydrogen bonding, dipole-dipole, London dispersion, completely non-existent. And that's why a phase change from a liquid to a gas takes so much crazy energy, 7 times more energy than just melting, because you have to break all the intermolecular forces. So there's no intermolecular forces, no attraction or repulsion between gas molecules. Okay, number 4, the volume of gas molecules is negligible. Kind of a crazy word right here, negligible. It means that it doesn't count, it doesn't matter. And here's the reason why. Gas molecules are super crazy small. The distance between one gas molecule and a second gas molecule is so great in comparison to the volume, the amount of space that each gas molecule takes up, that it's as if that volume doesn't even matter in comparison to the space. So we say that the volume of gas molecules doesn't count, it's negligible. Now here's the mistake that students will make on this. They'll think, oh, volume doesn't count. Now the volume of the container matters. I have gas in a 1 liter container, a 2 liter container. That totally matters. The volume of the container, that matters. What is negligible is the volume of the gas molecule, the individual gas molecule, how much space it takes up. That's negligible. Doesn't count because it's so small in comparison to the distance between it and another gas molecule. Okay, last one. The kinetic energy of a gas molecule is proportional to temperature. So let me write this as a summary. As kinetic energy increases, that tells us that the temperature must have also increased. So really a good visual for you. If you increase the temperature, the gas molecules are going to begin to move faster. And if you cool down gases, less kinetic energy, they move slower. Watch the video on kinetic energy and gases. It brings into relationship the mass of the gas molecule. So there you have it, the 5 postulates. Have these memorized. These are really good to have memorized as you move into the gas unit and you start talking about theory questions. All right, good work. Chemistry, you're doing great. Watch the other videos on gases to get you up to speed. Thanks, bye.